Good day, my highly esteemed viewers. You are welcome back to class. Last time, we talked about some properties of elements that show periodicity. And indeed, we talked about two of them, which are ionization energy and electron negativity. Today, we are going to conclude it. Remember, I said there are other factors, there are other properties that show periodicity. They are all in the previous videos. So go to those videos and you see them. But if you have any questions, don't forget you write it in the comment section and I will answer you as soon as possible. So next one, we have already dealt with these two. We are going to talk about these remaining two. So let's delete this one here. Let's erase it. So we are considering this 3 and 4. Now, atomic radius, just like circle and the radius. Atomic radius, by definition, is the distance between the nucleus, which is the center, and the valence shell. That is the distance between the nucleus and the valence shell. For example, this is the nucleus surrounded by the electron cloud. You see, the distance between this and the valence shell, that's the atomos shell, forms the radius of the atom. That's the definition of atomic radius. However, as we already know, the radius of an atom is difficult to determine. In order to determine the radius, because of the movement of the electrons around the nucleus in the electron cloud, it's always moving. So remember, electrons are always in motion. So because of the motion of the electron, it's not difficult to find the radius directly. So in order to determine the radius, you have to consider two touching atoms of similar electronegativity value, two similar covalent atoms of similar electronegativity value. For example, you can use chlorine, you can use fluorine, two fluorine, not chlorine and fluorine. Let's say you are using two chlorine. Let's say these two chlorine, this one chlorine, you have another chlorine like this, chlorine like this. You now determine the place where the repulsion is first moved. So this is the radius here, and this is the radius here. So you now add the two radius, divided by 2, you have the radius. So that's how you determine the radius of an atom. Because of the motion of electron, it's difficult to determine directly. Instead, you look for two covalently bonded atoms or two atoms of similar electronegativity value. Find the radius of the two, the place at which repulsion is first felt most. So you determine it, measure it, and have it. So that's how you determine the radius of an atom. The ionic radius. Ionic radius is also similar to atomic radius. Remember, for radius of an atom, how does it affect elements in the periodic table? It's similar to ionization energy, the way it affects it. As you move from left to right, when we explained ionization energy, we said the more electrons are being added to one shell along the same period. As more electrons are added to one shell, the nucleus is pulling them. The more the electron added to one shell, the more the nucleus pulls them, making the atom to shrink, making the atom to become smaller. There, and since the radius is the effective nuclear charge is pulling it, making it to be smaller, therefore the radius also will decrease. Therefore, as you move from left to right across the period in the periodic table, the radius of the atom decreases in size. But as you are moving down the group, you see that one shell, another shell is being added, making the radius to increase in size. That's how it affects elements in the periodic table. Decrease from left to right, increase down the group. Then you have ionic radius. Ionic radius is similar, only that in this case, we are going to compare an atom to its ions. That is, whether it's positive, electropositive element, it has lost electron, or electronegative, it has gained electron. It affects the radius, the ionic radius. Let's say, for example, we are using sodium, Na. The electronic configuration is 281. Remember, the atomic number is 11. Then you have the one that has already given out electron, it gives out this single electron. You have Na plus 28. So it assumes that it has lost a shell. You see it. Therefore, the neutral atom is always, the radius of an atom is always bigger than the ion. Let's use magnesium also. Any of the metals, magnesium, you have 282. You have magnesium 282 plus. You see that this one has 3 shells, this one has 2. So it's assumed that, or it is known that the radius of a metal like magnesium is always bigger than the radius of its own ion. That is for electropositive element. Then let's go to electronegative element. For electronegative elements such as fluorine, you see it, this is 2, 7, making 9 because the atomic number is 9. But when it takes an electron, it now becomes F minus 2, 8 in order to form the octet configuration. So you see that it's assumed you are breaking a separate shell. Assumed you are breaking a different shell entirely from a different element. You are breaking a different shell to add to it. You see it. Therefore, it increases it, meaning that the size will increase. Therefore, the radius of an atom, electronegative element, is always smaller than that of its ions. Similar thing applies to chlorine. Chlorine is 287. It's always smaller than chloride ion, 288. You see it? Because it's assumed that you are adding a different shell entirely because of the negative charge it now has. That is that on ionic radius. Then the last part of it, what if we have different ions? For example, we have sodium, we have aluminium, we have nitrogen, we have oxygen, yes, we have fluorine, and we have magnesium. The simple explanation of this is this: because of the effect of the electron cloud, once the nucleus is having effect on it, it shrinks. You see it, because of the effective nuclear charge and the pull of the nucleus on the outermost electron, it affects it. But in summary, in short form of it, is that for a mixture of these ions, the radius increases as the atomic number decreases. So most often, the question you can be asked here is, they will give you this so many of these ions and tell you to arrange it in order of either increasing or decreasing radius. So remember, as the atomic number increases, the radius decreases, or as the atomic number decreases, the radius increases. So let's arrange it now in order of their increasing radius or size. So you have it like this: as the atomic number increases, the size decreases. Therefore, aluminium 3 plus, remember this is 11, this is 13, this is 7, 8, 9, this is 12. Therefore, aluminium is first, lesser than magnesium 2 plus, lesser than sodium plus, lesser than fluoride ion minus, lesser than oxygen, lesser than nitrogen. You see it? So for this mixture of ions, as the atomic number increases, the size decreases. So this is how you arrange it. This is the arrangement, and these are the kind of questions they normally ask. Is application centered. So note this very well, very well, for any exam, whether you are in a lower class or preparing for external exam. It is this one they normally ask you. Thank you very much for watching my video. Please, as you always know, I appeal to you, help me to share it to your friends. Since you are on holidays now, share it to your friends, let them benefit from it. And also, don't forget to subscribe. God bless you, my good friends. Thank you.